So I captured this part for Alex. So he knows there's a typo in that question. What was that again?
Question 3.
3 Roman figure 4 of the last worksheet. The worksheet on Pythagorean identity. So there's a typo there. That should have been 1 plus in the first bracket. Okay, now to compound angles. I think I captured this and half of this. So once I move beyond half of that, somebody should help us that. So what we want to do with compound angle, like I told you, like I said a couple minutes ago, the formula, there are 6 of them, are in your formula booklet. So no need to memorize. But we're going to go through it together to see how we could prove it. And we're going to use it to prove some things later. So you need to get used to how to prove stuff. So that's why I thought it would be necessary for us to prove it together. So basically, here, the intention is to see what happens to the trig identities, what happens to trig ratios of sum and difference of angles. Basically, that's what compound angle is about. Okay? Let's start with cosine. It doesn't matter which one we start with. Compound angles. So let's see. Here we will discuss the trig ratios of sum and difference. So something like maybe x minus y, a minus b, p plus q, what happens to their sine, cos, and tan. Again, we go to the unit circle. You know, everything we talked about unit circle to look like this. Again, we go to the unit circle. Suppose we have a unit circle. This is like the easiest way to show it. There are other ways, complicated diagrams. This is the easiest way to show it. Of radius 1, of course. The unit circle has radius 1. Now, suppose P is in the first quadrant. This is P. And suppose Q is in another quadrant. Now, suppose the angle, maybe I use different color now. Suppose the angle of inclination for P is A. Are you with me? And Q is here. The angle of inclination for Q is B. Can you see? The angle from the origin. Okay? Now this is Q. What are the coordinates of points here? And what are the coordinates of points here? We talked about it the last time. P is what? Sine A. Sine A.
And then cos A.
Cos A. Do you all agree with that? Close. Cos first.
Yeah, cos. Oh, okay, sorry.
Cos first. Cos A, comma, sine A. That's the coordinate of the point. What about Q?
Cos 180
Cos what?
cos 180 minus b.
Cos 180 minus B. So what is that? Here, the 180 minus B in the second quadrant. Let's see. Let's see here. So this is what we have. Yes?
Yes.
Yeah.
So this is 180 minus B.
Yes.
If you cross multiply,
Isn't it cos?
it wouldn't matter
Right.
which one you use.
And the X and the Y. X is negative,
Switch. When the angle
isn't it?
Yeah.
So we have
Negative cos.
wait a minute. If this is 180 minus b, yeah, this is an acute angle. Okay. So if you do sine 180 minus b, you get what? Y over y, right? And similarly, cos 180 minus b is x over 1, which is x. And I don't know if we discussed the periodic nature of sine and cosine. We should have discussed that previously.
I think I talked about it
When?
in my.
Yeah. Okay. So nobody has seen your E yet. Periodic nature. Press your calculator. Are you there yet? Is it okay to write this as cos negative b plus 180? Right? Would it be the same to say minus b minus 180? If b is very large? Will it be okay to say this is exactly b minus 180? Cosine is an even function. Okay? Anyway, that's not what we're trying to do. Now, press sine of 180 minus bracket, then put any number of your choice, any value of your choice. Now that value, are you in radian or degree? Make sure you are in radian. You are using 180. If you're in degree, use 180. If you're in radian, you use pi. So 180 minus. Now whatever value you put for p, for b, press sine of that value again. Tell me what you notice.
Same value.
Same value. Are you there yet? Yanko, I'm waiting for you, and you as well.
I'm confused.
Oh.
We're supposed to have sine 180 and then minus 180.
Sine 180 minus something, then cos of that, sine of that same thing. So if you have sine 180 minus 30, then press sine 30.
Oh.
You got the same thing. Okay, quickly, please.
Yeah.
So basically, what I'm trying to say is that this is exactly sine b.
Oh, yeah.
Okay.
I did it. I did it.
When you guys are done, tell me.
I got
can
it.
waste our time, but let me know when you're done. So this is sine b.
Yes.
So there's no need to write 180 minus. That's the point.
Yes.
But let's check that, of course. Pick any value of your choice. Cos maybe 180 minus b is an okay. Wait. One thing we forgot to include. Please listen. One thing we forgot to note is that our b is actually more than 190. Although a and b could be anywhere, even b could be in the first quadrant. Okay, it doesn't have to go extra like to the second quadrant. Because the idea is to see what happens when you combine a plus b and when you combine a minus b. We are trying to find the difference in angle. Basically, our angle that we are trying to consider is actually here. Okay, so even if this is going to actually be a problem, I should restrict it, because if you are going to find the cosine of something, you might end up getting something negative if it is more than, if it is not an acute angle. It's going to give us a negative. I don't know if you are getting my point. Cosine of 180 minus 150 is cos 30.
Yes.
That would be a positive number. But if you find the cosine of b, which is that 150, you get a negative number. So you might think, oh, maybe it's not exactly the same. And that's because we're in the second quadrant. Remember, this is y. Y is always positive. but we are dealing with x,
Which is negative.
which is negative. So even if this is giving us negative, it's still our cos b, not negative cos b. I don't know if that makes sense to everybody.
Okay.
So what I'm saying is that so this is meant to give us negative cos b eventually. However, x is negative itself. Understand?
Oh, yeah.
So x is negative itself because we are here. So the easiest way for us will be to restrict A and B to the first quadrant. Let me restrict A and B to the first quadrant. So we don't have to worry about this problem. Okay? Please pay attention. All right, here. Pay attention. Let us restrict B to here, such that this is your B. It's greater than A, that's the point.
So this would apply as long as B is greater than A?
Yes. Because we want to find the difference. You can't find the difference unless one is greater than the other. That's the point here. Okay? So this is B. Or that could have been A. Anyone could be A or B. It doesn't matter.
Yeah.
Alright? So, and this is your A. So basically, there's an angle between them. Right? This angle is between them. This angle is what?
B
minus A.
Good. Okay? Now, the coordinate of Q, just like we have found the coordinate of P, the coordinate of Q will be what?
Cos B,
Cos B,
sine B.
Sine B.
sine B. Okay? Now, we are going to now look at this using something that we have known before. Two things we can apply. We have a triangle that looks like this. It's not, yes, an isosceles triangle. That's probably all we know about it. We don't know if it is acute or obtuse. We don't know how large is B minus A, right?
Yeah.
Mhm. And we don't care actually. So this is my P. This is, let me draw that in a different way. I'm going to write a short description of what we did here. I'm just trying to make it fast a little bit. So no need to look at obtuse because this idea might be confusing. Let's just stick to the acute in the picture. So if you look at your references, the reference material, it might be done in a slightly different way. Okay? Now, we can come up with a triangle that looks like this. This is 1, this is the origin, this is 1, this is P, with coordinates cos A, sine A, and this is Q, with coordinates, cos B, sine B. Okay? We're going to find PQ in two ways and see what happens. There are coordinates. You can find the distance, you can use distance formula first.
Yeah.
Wait, the angle between here is B minus A. Right?
Yeah.
So without referring to the angle, our PQ by distance formula. Again, no one is going to ask you for this proof. But the way you reason when you prove is some of the things I want you to gain whenever I am proving something. Okay? By distance formula, do you know distance formula?
Yes.
No.
Okay?
I just don't remember.
Yeah, okay. If you have x1, y1, x2, y2, Yanko from IGCSE, if this is A and this is B, distance AB is what? The square root of
x2 minus
x2
x1
minus x1
squared,
squared.
and then plus y2 minus y.
Exactly.
Okay, okay, that's
Or
fine.
better still, we could just say AB squared is equal to, right?
Yes.
Without, so that's what we are talking about here. Okay? It's alright to forget. So similarly, what is my PQ squared? Together.
Cos
minus cos
B.
A.
Cos B minus
Cos
cos
A.
A
All squared.
all squared. It could have been cos A minus cos B all squared.
But
It doesn't
it's
matter.
squared, so it doesn't matter.
It's because it's squared, yeah, it doesn't matter.
One.
And sine B minus sine A all squared. So let's open the bracket together.
Cos
Cos
B
squared B
B
minus
minus
cos
2
cos A cos B
plus
Plus
cos
cos
A
squared A
cos 2
cos squared A, right?
Yes.
And the second bracket,
plus
Plus
sine
sine
squared
squared B
sine squared B
plus 2
plus
minus
sorry.
2
Sine
sine
A.
A
2 sine A
Sine A
cos A
Yep, cos
plus, no, 2 sine A sine B plus sine squared A. Right?
Yes.
Some things can be collected based on what we know. What are those?
sine squared theta.
Where do you get theta?
Sine squared
I can't see
B
theta on the board.
plus cos
Can you see
squared
theta on the
B
board?
is
No.
Okay, so why do you bring in theta? That's my point.
uh,
Yes,
cos squared B plus
Cos squared
sine
B
squared B is 1.
and sine squared B will give 1.
Cos squared
Yanko, can you think of another one?
cos squared A
Mm-hmm.
plus sine squared A.
We also give
Also
1. Nothing can be done for these two for now. Okay, so we collect the like terms. Cos squared B plus sine squared B. Yes? Cos squared A plus sine squared A, and sine could have come first, it doesn't matter. Minus 2 cos A cos B minus 2 sine A sine B. So this is 1, this is 1. So we have 2. 1 plus 1. Then this is maybe just minus 2 bracket cos A cos B plus, right?
Yep.
Sine A sine B. So basically it is 2 minus 2 bracket cos A cos B plus sine A sine B. Let's call this equation. Okay? Now, which other way that you know from previous knowledge, what other way can we use to find PQ? Not you. Yes, you, yeah. From previous knowledge. IGCSE, actually. Wanna try?
Triangle. Like using the isosceles triangle.
What does it satisfy?
Because you have two sides that are the same.
So how do we find PQ? There is something you can use directly.
Firstly,
Because I haven't reviewed it in coliform 5. Come on.
your own formula.
Cosine rule.
Oh, right, yeah, those things.
Yeah.
Cosine rule. Okay, so let's apply cosine rule.
This side.
We just did sine rule, so that's why if I had done cosine rule with the class, so maybe you will remember. Remember cosine rule? Let's take it here. If you have triangle ABC with angles A, B, and C, what is the cosine rule beginning from A? A squared is equal to
B
B squared
Plus
plus
C
C squared
minus
minus
cos.
no,
No, not cos.
yet.
4.
No. 2BC
Cos
plus
A.
but the
big A.
big A,
What's
yes.
wrong with you guys? This is a child. You should remember this stuff.
Is this in our formula booklet?
Well, I don't know. I can't remember. I'll check.
Okay.
Anyways, so basically, if you're applying cosine rule to get this, it's going to be this square plus this square, minus 2 this, cos of the angle. Whatever side you are looking for, it is the cosine of the angle. while you use the others in between. So basically I have, if I state it, I have PQ squared is equal to OP squared, OQ squared. Yes, take it over from here.
Minus
2
OP
OQ cos
B minus A.
Yeah, but I'm just going to write it as ABC first. That's done. Okay, so this is going to be PQ squared is equal to 1 squared plus 1 squared minus 2. What is OP?
Times 1 times
1 again, then cos B minus A. So clearly, this is simply 2 minus 2 cos B minus A. Look at equation 1 and 2. They each represent what?
The
The same thing. So we can equate 1 and 2. If you equate 1 and 2, what does that give together?
Start from this one.
We can start from maybe this one. Because
Okay.
2 negative
minus
2 minus 2 cos B minus A is equal to
2 minus 2.
Then 2 minus open bracket cos A cos B plus sine A sine B close bracket.
Close bracket.
You can cancel.
so 2 we cancel.
Yes.
Even minus 2 can be divided by both sides. So if 2 cancels, we have negative 2 cos B minus A, negative 2 bracket twice. I'm having a class. Thank you. I don't want to remind us. Is it the end of the period? Okay, then you can leave quietly. Thank you very much. Like I said, quietly. So we have cos A, cos B, right?
Yeah.
Plus sine A, sine B. Okay? Now, what does this mean? If you are finding difference of angles for cosine, you take the cos of each of them plus the sine of each of them. Okay? So if it is cos x minus cos y, it doesn't matter which one comes first. Usually B will come first. The first one will always come first. Understand?
Yeah.
Okay? B will come first. So that will be cos B cos A minus because B star. I should have drawn my picture such that it's A minus B, but it doesn't matter. Understand? Now, the next thing we want to do.
Is it recording this time?
I
Yes,
hope you changed it. Okay. So let's call this equation 3. Then we write the summary later. So we have one of the compound angle formula. The rest will be generated from here. If we change A to negative, if A changes to minus A, if A becomes a negative, so we're going to have cos B minus minus A.
So visually put minus AB in the fourth quadrant.
We are not talking about quadrants here. Focus on equation 3. It's equal to cos negative A. What I did is irrespective of any quadrant, so don't bring in the quadrant argument. In that case, you are restricting it. We are not restricting. This is in general. Cos B plus sine.
Negative A.
Mhm.
Sine B.
What can you say about this? So this is cos
Cos A plus
A plus B.
B plus A. Let's just go with that order first. What is cos of minus A?
Cos absorbs the
It's
negative.
negative. So we get
Cos A.
cos A back. Then cos B. Yes?
Yeah.
Sine moves the negative to the front.
So we get what?
Negative
Sine
sine
A,
A, sine B.
And B. So addition gives us minus. Subtraction gives us plus. The same thing. Understand?
Yeah.
So these two, we can actually summarize it. Okay, maybe we shouldn't summarize first. When summarizing, I'll write it in the way we normally write it. So this is equation 4. Now we need sine. We can get sine from cos by applying the complementary angle that you guys talked about. So if I need to get sine of this, I could consider cos of 180 minus a plus b. Something like that. No, cos of 90. This is automatically sine a plus b. Do you agree?
Yep.
And because I already know, so basically my 90 is my b, and my a plus b is my a. And then I will get that of sine. Okay? And similarly here, if I need my a plus b for sine, I could apply the same idea. Okay? I use cos 90 minus a minus, oh, I did that of a plus b first actually, not a minus b. You get what I mean? So we can apply it in this way. So, but for the cosine, let's summarize this. Then I give you some time to write, then I put the sign over there. So in summary, so this is how we write it, a plus b, or I could say a plus or minus b, but maybe I separate them. And cos a minus b is equal to cos a, cos b minus sine a, sine b. And this cos a, cos b, please write, plus sine a, sine b. So this is the identity to be used. You don't have to memorize. I'm sure you have it in your formula booklet. So when I'm doing this with the SL, you guys wouldn't need to worry about it. You move on to something. But SL also with this. No need to take the picture, right? Since we have the video.
Yeah.
Oh, Mr. Daniel, I thought
Yes.
you're supposed to write a note down there.
Yeah. Sure. So say, consider two points P plus A, Q plus B sine B. Circumference of a unit cell. Oh gosh, I'm moving this fan, whatever it is.
That's why I was standing there.
Okay, so I took your spot, sorry. The tan is the longer one, so we can do that too. Then I'll take some examples. This worksheet will be for today and tomorrow, so it's not just today.
Mr. Daniel, do you have time maybe very much or something? Because I have another question.
Okay, yeah. This is the only class I have today.
Oh, you can just do just for us.
you to pause the notes. I need you to look at page 1 of the worksheet. The middle column is about cos. Okay, can I ask you to apply these two identities to this question? So let's look at the format. Cos of A plus B, I've rewritten it in a different way. Or should I change it to X and Y so it's not confused?
Sure.
I change it to X and Y, is better?
Yeah.
Okay, so let's change it to X and Y. So let me explain. If you have two angles being added, cos of the first, cos of the second, in both cases